Welcome back. This is our first video out of the series of videos on AC analysis. And in today's video, we want to express the sinusoidal waveform VFT into standard cosine and then determine its amplitude, frequency, period, and phase angle. So to do this, we would like to, well, not like to, we would want to use a useful trigonometric identity, and that is to express a negative sign to positive cosine. The identity that we should use is cosine x equal plus or minus sine x plus or minus 90 degrees. By using this, we see that we have a negative sign. So here we have a negative sign, so we add positive 90. So we go ahead and add 90. We can write 10 to the 3 as E3, e to the third. And adding 90 to negative 45 gives us, well, just write that out, plus 90 degrees volt. And this equals cosine, a positive cosine. So cosine 8 pi e to the third times t plus 45 degrees. So here we have VFT. We know VFT is in the form of A for the period. So in this case, we see that A, the amplitude, well, not the period, A for amplitude is 4 cosine 8. So that is omega cosine. So that would be 8 pi e to the 3, which is omega times t plus or minus theta. In this case, we have plus 45. So that is theta. So thus we have theta equal to 45 degrees. Amplitude is equal to 4. We know that our frequency in this case, our angular frequency is 2 pi f. Get our frequency, we divide basically omega by 2 pi, and that gives us 4 kilohertz. We then move on, and we know that our period is 1 over f. So thus we have 2 pi divided by omega, which is equal to 0.00025, which is ultimately 25 milliseconds. To see how the identity works, let's go to Desmos. Here we can start off by using, well, by just talking about sine and cosine. So we can look at sine, and we can look at, oh, I don't have a positive cosine. Let's get a positive cosine in. So we can look at sine and cosine. So if we use, in our case, we want to get cosine. So let's use sine as our reference wave. So if sine is our reference wave, to get cosine, basically the shortest distance we have to move sine would simply be 90. So to get cosine, which is the orange graph, we would move sine to the left by 90 degrees, and that is advancing sine. And if we advance sine, we move it to the left by 90, and thus we get cosine. So let's see that. And let's take a look at negative sine as well. Well, not negative sine, but sine reflected across the x-axis. So notice that when sine is reflected across the x-axis, we end up with sine. Well, the first, let's take away the white graph. So sine reflected across the x-axis, and then let's look at cosine reflected across the x-axis. So here we see that cosine, well, sine is from 0 is shifted negative 90, and we see that cosine is shifted 180. So as you can see in our voltage, in our sinusoidal equation that we had, v of t, we had a negative sign, which in this case, a negative sign is the green graph, and cosine. So to move our, in this case, our cosine to the right, we would have to add 90. And I know it's counterintuitive because when it's not reflected across the x-axis, we don't, whenever we put a positive value, we get it to move to the left. But whenever it's reflected across the x-axis, a positive value moves it to the right. So in our case, we can then look at the equation that we got, v of t, sine of x minus 45, that's what we had. However, the omega t, we didn't change, nothing is changed. The angular frequency isn't messed with in this case, and the amplitude is not messed with. We just use a standard sine. So then, if we add 90 as what we just did, so basically here is our, we add 90 to our negative cosine, and we end up with a cosine of 45. So that means that if we go around to Desmos again, we should get that, in our case, negative sine x, in this case, we add 90 to it. So it was 40, so it was 45, we add 90. And then that's supposed to be equal to cosine. And yep, cosine x plus 45. So both of these graphs supposed to be the same. And if that's the same, that means our trigonometric identity worked. So we can then go ahead and go take a look. So that means this is supposed to be equal, and there it is. Both are equal. And that's it for today's video. So I'll see you in the next problem. Bye.